Hello, and a warm welcome to all the audience of this course. I am your instructor, Dr. Gaurav Tyagi. I am an associate professor in the Department of Civil Engineering, SR University, Warangal, Telangana. We are continuing today in our second lecture on influence line diagrams, and this lecture is entitled Point Loads and UDL because in this lecture we are going to discuss how we can draw the influence line diagrams for different kinds of loading, and then for any arbitrary point loading or any arbitrary uniformly distributed loading, how do we calculate support reactions and shear force and bending moment at a given section. So these are our aim today. So let us proceed with the first part. So first of all, we might be given a question where we have to find out the support reaction as well as the support reaction and shear force and bending moment due to a given point load. Okay, so I'm taking an example here. There is a beam, simply supported beam, which is having supports as A and B. Its total length is 20 meters, and there is a point load located at a distance of 4 meter. Okay, from the left hand side at 4 meter, there is a point load of 80 kilonewton. Okay, and for this loading, you have to find out the support reactions, shear force, and bending moment at a section C, which is located at 8 meter from left hand. Okay, so this is your problem. So what you're going to do, first of all, draw the shear force diagram and bending moment diagram as I explained. Okay, how do you do it? So first of all, you will draw the ILD for RA. This is your ILD for RA. This is your ILD for RB. RB. This is your shear force ILD. And this is your bending moment ILD. Okay, this is one, this is one, this is the C point will be minus 8 by 20, and this will be plus 12 by 20, and this point will be AB by L. So if I do the calculation, it is AB by L, and this point is 4.8. Okay, so now once we have the ILD for RA, RB, shear force at C, and bending moment at C, now what you can do is you can calculate the support reaction due to 80 kilonewton load, because these ILDs are drawn for a unit loading. Okay, so RA for 80 kilonewton loading will be 80 multiplied by this H1. Okay, similarly my RB will be equal to 80 multiplied by H2. Okay, and third one, this is H3. So RC, oh sorry, VC will be equal to 80 multiplied by H3. and my bending moment at C will be equal to 80 into H4, right? So now you can do this. So you need H1, H2, H3 and H4. So finding H1, H2, H3, H4 is very simple. You have to simply remember this. A, A, B, B. This diagram you should always remember. And the relation from similar triangle is A by A equal to B by B. Okay? All of you should remember this result. A by A is equal to B by B. Right? So if you do that, for all these four cases, you can very easily find H1, H2, H3, H4. For example, for finding H1, you can do H1 by 1 equal to 4 is already this side, so this length is how much? This is 4, so this is 16. Similarly, this is also 16. H1 by 1 equal to 16 by 20. Similarly, for H2, H2 by 1 equal to 4 by 20. So from here H1 comes out 4 4 is 16, 4 5 is 20, 0.8. From here it comes 0.2. H3. To calculate H3, you will have H3 divided by 8 by 20 is equal to 4 by 8. So from here H3 will come 4 by 8 multiplied by 8 by 20. So this is 0.2. Okay. And similarly for H4, if you complete this triangle, you will have H4 divided by 4.8 is equal to 4 by 8. So H4 comes out 1 by 2 into 4.8 equal to 2.4. Okay. So now you can calculate RA, RB, VC and BMC in one line. So RA equals to 80 into 0.8. So let me just compress this diagram a bit. So this is RA. Similarly, RB is equal to 80 into 0.2. Similarly, we have VC equals to 80 into H3, which is 0.2, and bending moment at C equals to 80 into 2.4. So this is 64 kilonewton, this is 16 kilonewton, this is 16 kilonewton, and this is 192 kilonewton meter. Okay, take care of the units. Here the unit is kilonewton per meter, kilonewton meter. And in this question we learned that we have to simply apply this formula or a simple rule of similar triangles to find out the required ordinates of the ILD and simply multiply that ordinate with the loading value. Okay, loading value could be anything. So this we did for single point load, and in the next problem we'll do this for multiple point loadings. Okay, so here is the next problem. So in the same problem, we are going to change the question. Okay, so let's say you are having, if you've noted it down, I'll rub it. So now instead of 1 point load, we are having 2 point loads. Okay, so let's say here we are having 4, 4, and this is 8. So here somewhere 10 would be there. So this is 12. So let's say here at 5 meter, this is at 5 meter, we are having another point load. Okay, and its value is, let's say, 200 kilonewton. So let us find it out. Okay, so this is, we need to know this height, we need to know this height, we need to know this height, we need to know this height. Okay, so these height values will be, let's say, h3, sorry, h5, h6, h7, h8. Okay, so let's find out the h5, h6, these, all these values. So we know that h5 by 1 is equal to 4 and 4, 8, and 5, 13. So this is 13. So remaining is 7. Okay, this is 7 here, 7 here. So equal to 7 by 20. Okay, so h5 equal to 7 by 20. h6 by 1 h6 by 1 is equal to 13 by 20. Similarly, we have h7 divided by 12 by 20 equal to 7 divided by okay, and similarly h8 divided by 4.8 is equal to 7 divided by 12. Okay, so from here you can find out these values, and once you know the values, simply add them in the previous result. So your RA will be equal to 80 into H1 plus 200 into H5. H1, H2, H3 and H4 you have already calculated, and H5, H6, H7 and H8 I have just now written the expressions. So you have to simply multiply the ordinates with the respective load values. So H1 by into 2 plus 200 into H6, and we see, pay attention here, because this H3 is negative and H7 is positive in case of shear force. So this will be minus H3 plus 200 into minus H7 plus H7. Okay, and same thing you have to do for the previous one also. When you calculated the, due to single point loading, 80 kilonewton, when you calculated VC value, there also it would be 80 into H3 with a minus sign. Okay, that I forgot to tell. So That's the thing. And bending moment at C will be equal to 80 into H4 plus 200 into H8. So once you calculate these values, you will have your results of RA, RB, VC and BMC, right? So you can solve this and we'll move ahead to the next problem. Now in the next problem, you are having a beam AB with a total length of, let's say, 40 meters, and at 15 meters you are having a point load of 80 kilonewton, and you are having a UDL starting from 5 up till 30, and its magnitude is 25 kilonewton per meter. Okay, so you are having a combination of a point load and a UDL. So how do we find out the four stress functions, namely reaction at A, reaction at B, and shear force at C, and bending moment at C for this particular load combination? So what we saw in the previous problem, that if you have point loads, we simply multiply the point loads with their uh, respective ordinate values in the influence line diagram, right? And now in case of UDL, we have to multiply the UDL intensity with the area of the influence line diagram which is falling below my ILD. So that's the entire trick. We have to multiply the UDL intensity with the area of ILD which is falling below the UDL. For that I need to draw the ILD first for this particular question. So I'm going to create some space. Hmm. So now let us draw ILD for RA. Is my LD for RB. It's for shear force. For bending moment. Okay, for ILD we are having this value is 1, this value is 1, and this value, let's say I call it A, I call it B, I call it C. So let us calculate the A value. So to calculate A value, I know that A will be equal to minus 15 by 40. This total length is 40. So this is 15 and the remaining is 25. Okay, so this is minus 15 by 40, L equal to 40 meter, L length of the beam. Okay, 40 meters. So A equal to minus 15 by 40, How much is this? We can calculate. My 15 divided by 40. This is 3 by 8. Similarly, with the minus sign, b equal to 1 minus 3 by 8. This is 5 by 8. Okay. And c value will be 15 into 25 divided by 40. So this will be 15 into 25 divided by 40, which is equal to 75 by 8. Okay. And we also have to find out. So let's say I am writing this is in points. This is 9.4. My a value 3 by 8 is 0.34. My b value will be 5 divided by 8, 0.63. Okay. Now I have drawn the straight lines. Now I need this area for UDL. This color might not be visible. I need this area. I also need this area. And we need this area. Okay. So the solution would be RA is equal to 80 into this height, whatever is this height, H1, and here it will be H2, and yeah, so RA calculation. RA calculation is, so now you see here is a small important concept. The way the problem has been framed, there is an important concept that the point load is exactly on the section where we are interested in finding the shear force. So for shear force, should we take 0.34 or 0.6 as my height? The answer will have two parts, maximum negative and maximum positive, in the sense that what is the negative shear value and the positive shear value at point C. Okay, so that one would be there, because exactly at C point the shear force value is 0, but slightly left of it the value is 0.34 and slightly right of it is 0.6. So we have to report these slightly left and slightly right values. Okay, so that one needs to be done. So let me find out first of all H1, H2, H3, H1, H2, etc. I need to find out. So first of all, finding the h1. So h1 by 1 equal to 25 by 40. Similar, so this will come out to be 25 divided by 40, 0.63. This is 0.63. For h2 we will have h2 by 1 equal to h2 by 1 equal to 15 divided by 40. Okay, so this is 15 divided by 40, 0.34, 0.38, right? So now we can calculate this value also. This value, let's say this is my h3 and this is my h4 and this is my h5, this is my h6 and this is my h7 and this is my h8 and this is my h9. Okay, all these heights you need to know if you want to find out the areas of the shaded portion. Okay, so let us start one by one. h3 h3 by 1 equal to, it is still, for example, this length is 5 meter, for example. Okay, and this length is let's say uh, this is 25, right? It is already given to me. So h3 divided by 1 is equal to 35, no, not 35. h3 divided by 1 equal to 5 divided by 40. So h3 comes out to be 5 divided by 40. The answer is, the answer is 0.13. Okay. Similarly, you can find out h4. h4 will be equal to h4 divided by 1 is equal to uh, this length. This length is given to me as, let's say this total is 25 and this is 15. Okay, h4 divided by 1 equal to 15, no, not 15. h4 divided by 1 is equal to 10 divided by, because this remaining length will be 10 meter. Okay, So now here you can see I have already done the calculation of heights up to h7, and now we can calculate h8 and h9. Uh, it would be h8 divided by 9.4 equal to 5 divided by 15. Okay, so the value will be 5 into 9.4, 5 into 9.4 divided by 15, 3.1, and h9 divided by 9.4 equal to 10 divided by 25. So this is 10 into 9.4 is 94 divided by 25. This is 3.7, 3.8. Okay. Once you know all these heights, then you can do the calculation of areas. So for RA, your RA will be equal to 80 into H1, which is 0.63, plus 25 into area of this trapezium. So it will be half base 1 plus base 2. This one I did not find. Okay. H9, this is H10. Okay. So H10 divided by H10 divided by 35 is equal to 1 divided by 40. So H10 will be 35 divided by 40. 0.88. So half base 1 plus base 2 into height. What is the height? So this is 15 and this is 10. So 25. Okay. This is my expression. So if you calculate this, you will get 80 into 0.63, 80 into 0.63, 3 into 0.63 is equal to 50.4 plus 25 into this will be 0.88 plus 0.25 divided by 2 into 25 into 14.125. And similarly, you can do the calculation for other parts also. Okay, so the final answer would be 50.4 plus 25 into 14.125. Okay, so 358.53 kilonewton. Similarly, you can find out all the areas and calculate the support reactions. Only small thing will come for shear force that I am calculating here, VC. So VC will be VC minus and VC plus. That means just to the right of C will be VC plus, and for just to the left of C will be VC minus. So in this case it would be 80 into 0.34 plus green area into W. This is UDL intensity W. And for VC plus it will be 80 into 0.6 plus the same thing, green area into W. If you want exactly at VC, so it will be 80 into 0 plus green area into W. Okay. So generally we report these two values, just to the left and just to the right. Rest all the things are fairly straightforward. Thank you very much.